three-dimensional chain rule, and the directional derivative. Start with our standard construction. Standard meaning z is a function of xy, and we'll use the default parameterization. The coordinate variables x and y are my parameters. Take every point in the xy plane, feed those points into the z equals f of xy, and I get curves on the surface. Tangent vectors, tangent plane. Now we'll take a line in the xy plane, which gives us another curve, and another tangent vector. I'll take a unit vector for the slope vector for this line, and then we saw that the corresponding tangent vector is in terms of the dot product and the gradient. This k term is the directional derivative. This curve has a vector form, and so the derivative is also the tangent vector. Comparing components. That's the chain rule. Z is a function of xy, so z prime is f prime. F is a function of t, because t gives you an xy, which then gives you a z. So f is really a function of t in this case. Definition. The way we've been constructing things, this is the standard definition for directional derivative, and the two different notations. Given any other vector dot product, you can always pull out a scale, and it's just a scale of the directional derivative. Let's do an example to illustrate the construction we're doing. Z is a function of x and y. We'll just put down a brief schematic. We're looking at a point and a vector. It doesn't have to be unit vector, but it's standard, because might as well make directions a unit vector. That gives us a line that we plug in to the function, because every point on the line is in terms of t. That xy pair we plug into the function, and we get a space curve. In parametric form, x, y, and then z is f of xy. The vector form points to the point. Tangent vector is derivative. This is our tangent vector from before, but it's also dx dt, dy dt, and dz dt, but since z is f, it's df dt. Taking the parcels of f, and now let's just compute df dt using Calc 1. product rule. And put in what those symbols are in terms of the parameterization. Collecting derivative terms. There's our dot product. Expanding out what U hat is. That's our chain rule. Notice that nothing in the construction required U hat to be a unit vector. We just did it because it's standard.